Welcome, learners. In this video, we will talk about the abstract contract as an advanced topic in the Solidity programming language. Okay, in Solidity, an abstract contract is a contract that contains one or more functions without any implementation. It serves as a blueprint or a template for other contracts to inherit from it, okay? Abstract contracts cannot be initiated on their own, but they can be used as a base contracts for derived contracts. So the purpose of the abstract contract is to define a common interface or a set of functions that derived contracts must implement. It establishes contracts structure and specifies the functions that must be present in any contract inheriting from it. So abstract contracts are useful in scenarios where you want to define a common set of functions or requirements that multiple contracts should adhere to. Okay, by creating an abstract contract, you can enforce consistency and ensure that all derived contracts implement the necessary functions. So in this example, an abstract contract is created, which is inherited by another contract that has implemented all the functions of the abstract contract. Abstract contract instance is created in the calling contract, and an object of the child contract is created. Using the object of the child contract, all the abstract functions that are implemented in the child contract are invoked. So let's go to this code line by line. Okay. So the first two lines here, it's specify SPDX license identifier, okay, and these are the comments, as we said in the previous videos. These lines about the abstract contract here, abstract contract, this block of code defines an abstract contract named abstract contract. So the name of this abstract contract is abstract contract. This one is the name, okay? It contains three functions. We have here get str and set value and get and add. So here add, set value, get str, okay? These functions are declared as virtual, indicating that they are abstract functions and don't have any implementation within the abstract contract. Okay, so this is the three function and it's virtual and indicating this abstract functions don't have any implementation within abstract contract. Okay, let's go to the contract, derived contract. This block code defines a contract named derived contract, here, derived contract, that inherits from the abstract contract using is, okay? So derived contract inherits from abstract contract. This one is abstract contract, okay? The derived contract provides the implementation for the abstract functions defined in the abstract contract. It defines the private variables, num1 and num2, and implements the get str. Here, get str, we add the implementation of this function here, okay? So also the add function and set value. So functions, according to its specific behavior, we add the implementation here. So the override keyword is used to indicate that the function are overriding the abstract functions, from the parent abstract class. So we add override. This keyword means these functions are overriding the abstract functions from the parent abstract. Okay. Here we have a block of contracts, this one, call contract. This block of code defines a contract named call. It creates an instance of the abstract contract name ABS here. So creating an instance of an abstract contract, which is ABS, and initializes it with a new instance of the derived contract. Here is initializes it with a new instance of the derived contract. The get value here function calls the function from the ABS instance, demonstrating the usage of the abstract contract and its derived implementation. Okay, so this is the code. We can see the implementation of this code. Of course, after writing the code, we choose the bottom of compile. We compile this code, then we choose the contract here call. Then we can go to the after deploy, we can get the output. So we can see that from this code abstract. This is the abstract contract, okay, and the code, the function with the virtual, this means no implementation for function in the abstract contract. Here, derived contract inherits from abstract contract, and in this contract, we add the implementation for each functions, and we have here two private variables. And this is the call contract, and we initializes here the instance using a new. Let's compile this code. After compile it, we go to deploy it. But we first choose call, okay, and then deploy. Then we can go to the get value. We should see here the result of we added here return solidity. Okay, so this is the result. So after successfully compiling the smart contract, we need to deploy it. Before deployment, we can call the contract from here. From here, we can call the contract into to interact with its functions and verify its behavior. To retrieve the output smart contract, we can use the provided functions. In this case, we have get value here function. By calling this function, we can see the output in the console log here, okay? So in summary, this Solidity code demonstrates the use of an abstract contract to define a common interface with abstract functions, and the derived contract implements the abstract functions according to its specific behavior. So the abstract contract ensures that any derived contract adhere to the defined interface. The call contract shows how to create an instance of the abstract contract and interact with its functions through the derived contract implementation. Okay, thank you for watching.